Hello and welcome guys. So in the last video we discussed about the text processing technique. So what are the different techniques using which you can do text processing? We created this basic text processing notebook here. We discussed everything in detail. So in this video we are going to start this project. Whatever concept we learned in the last video, we will apply those concepts on our data set and we will try to clean our data set. Okay, I have seen in the comment that few of you are facing difficulty in installing TensorFlow. So if you do directly pip install TensorFlow, then you will be able to install TensorFlow with CPU support. So this TensorFlow library will only use CPU, it will not use GPU. And if you have GPU and you want to optimize your training time, then I have already created one deep learning project setup video, so you can watch that also. And here I am going to give you one additional way to install TensorFlow. So if you have Conda, then you can first create your environment by using this command. You can directly create Conda create, and you can give your environment name and with the Python version. So here I have taken this Python 3.8 to avoid any dependency conflict. I have tested it and it's working fine on this version. And after that you have to activate your environment, and then you have to install your TensorFlow GPU by using this command conda install TensorFlow GPU. So once you use this command, then TensorFlow GPU will get installed in this environment, TensorFlow environment. Okay, so after that, if you restart your VS Code or something, then you will be able to see here your TensorFlow environment like this. Okay, like I am seeing here my TensorFlow environment. Okay, so you can follow this, and if you want TensorFlow with CPU support, then you can directly do pip install TensorFlow. We also need here NLTK and BS4. So you can install this NLTK and BS4 like this. Okay, so I have activated my environment. So I have selected my kernel TensorFlow. Okay, so I'm starting this project. So first I need NLTK in this, and next one is pandas, and let's import numpy also, and TensorFlow, import TensorFlow as TF, and from BS4 I want to import beautiful soup. So this package why I am using, I will tell you later. And from nltk dot tokenize, I want to import word tokenize. This we discussed in detail in the last video. And I also want string to retrieve all the punctuations. And let's import one more thing from nltk dot stem I am using, and I want to import wordnet lematizer. I can also import porter stemmer. Okay, so I'm running this. So after this, I want to first download all the NLTK package. So here I'm writing like downloading NLTK packages. First package I want is nltk.download. So I want all stopwords present in English. So I'm writing here nltk.download stopword, and second one will be my wordnet lematizer. So lemmatization we are going to use. So for that I am downloading this wordnet package. So let's run this. So once you run this, if you don't have that, then it will download all these things. So here we have, so I'm getting here that packages are already up to date. Okay, now we will load our data set. So let's give here one markdown. So I'm giving here loading data set. So I'm using pandas, and this is my data set, IMDB dataset. So directly I will pass the relative path of this. So I will copy relative path from here and I will paste here. And after this, if I do data.head, then we'll see. Okay, so this is the data set we have. So our data set has this review column and sentiment column. Okay, so now we will perform data pre-processing. So before moving forward, first let's check whether we have some null values or not. So I'm writing here data.drop, drop NA I'm using, and I'm also printing here df.shape to see my data frame. So this data.drop NA will drop if there is any nan value present in this data frame, and I will check the shape. So right now I am getting here 50,000 cross 2. So, and let me check my data shape also. So data shape is also same, so it means that there is no nan values present in the data frame. let me print this. Okay, so this is what we are getting here. Now we will start our data pre-processing part. So first we have to load all possible punctuation. So for that I will use string library, this one which we have imported here. This string library we have imported. So string dot punctuations I will use. So it will give me all the punctuations. Okay, if I show you here, so we are getting all the punctuations. And second, I will import stopwords. So for that I will use nltk. We have already downloaded that. So nltk.corpus.stopwords.words I will use, and in this I will pass English. Okay, let me print it. Stopwords. So these are all possible stopwords. And I will also load my lemmatizer. I'm going to use WordNet lemmatizer here because we discussed in the last video that stemming is not accurate. So, and here we are solving sentiment analysis problem. So we need something accurate, and we don't have any constraint of speed and all. Okay, so that's why I'm going to use this. So what are the pros and cons of lemmatization and stemming? We already discussed in the last video. So if you are coming after that, then you definitely got the clarity that why I'm using here lemmatization instead of stemming. Okay, so we will start our text pre-processing. So before that, let me go through this example. So here, if you see, we have this HTML tag here. Okay, so let me show you this in more detail. So what I'm going to do, I'm going to take this review. So in this review column, I want to retrieve the first index. So this is the text in this second element of this review column. Okay, so in this text, if you see here, we are getting these things. This this HTML tags we are getting. It is not relevant, and it is not going to contribute in sentiment of this text. Okay, only these tags are important. So these tags are not making any contribution in the sentiment of this text. So these are irrelevant things. So we have to remove this. So for that, we are going to use this beautiful soup. That's why I have imported here. So beautiful soup is a way to manage these things. Okay, I will use here beautiful soup library, and in this I will pass first argument as this. Let me pass this and see what we are getting. Okay, so I'm passing this. This is my first argument. This is the text, or let me initialize it to text. Okay, so this is our text. Okay, so I'm taking this text here directly. So I'm going to take here parser as html dot parser, and what it will do, let me print it. So it's giving me like this. Okay, I want only text, I don't want irrelevant things. So that's why I'm going to use here get text. So if I do that, then here now we are not getting these things. Okay, so it's retrieving and giving us only the text. It's discarding these tags, or if there is some other tags present later or somewhere, then it will discard. Okay, so that's why we are going to use this beautiful soup. Okay, so let me use this beautiful soup, and I'm going to define one clean text function which will take text as a input. Okay, and first level, this text, whatever text we are passing here, it will pass to this beautiful soup, and we will get much refined text. Okay, text only we can write here, or only text. So this text will get passed, and this will give us only text. It will discard all the HTML tags if there is something present. Okay, now next step is we have to remove all the punctuations. Okay, so to remove all the punctuations, we have already discussed in the last video that I'm defining here text, and I'm applying dot join, and join is just to join all the list elements. And here I'm going to use this list comprehension technique, and here I'm just lowering all the characters, and I'm iterating over all the characters in the text. Okay, if char not in punctuations. Okay, so what I am doing here, I am iterating over each characters, and I am saying that if char is not in punctuations, then consider only that, and also we are doing here lower casing of that. So lowercasing and punctuation removal, these two things we are doing here. Okay, so if I return here this text, and let me show you something. So if I pass this directly here, and in this, if I pass this thing directly, okay, so let's see what is happening. So we will get everything in lowercase, and also we are not getting, okay, so here if you see, we are getting this thing. Why? Because we are not using this only text, so we have to use this only text here. Okay, so first level we are removing all the HTML tags and we are retrieving only the text thing, and we are passing that text, and then further we are removing all the punctuations from that text. Okay, now let's run this and see. Now here if you see, we are not getting that tags and all. Okay, so this is that. Here what we did, here we removed all tags, HTML tags, and here what we are doing, here we are lowercasing and removing punctuations. These all things we discussed in detail in the last video. Okay, so we are just using those concepts here. And now what we will do, we will tokenize it. Okay, so I'm tokenizing it. So first we are going to tokenize it. So I'm passing this text directly. So let me return this here and see what is happening. So here we are getting all the tokens. Okay, next what we will do, next we will remove all the stop words. Okay, so I want final answer in the text form. Okay, so that's why I'm going to give here space, so that my final text is space separated, all the tokens are merged, and it's space separated. That's why I have given a space. In this, first I will apply my lemmatization. On what? On char I will apply, and then I will use this here for char in tokens, or you can use here word, just not to get confused in this, because here we are not using each character, here we are using each word. Okay, each word we are iterating over this list. Okay, so I am iterating over this list, and I am applying lemmatization on each word. Okay, and what else I am doing, and also I am removing stop words. So here we are first removing stop word and then applying lemmatization. So these two things here we are doing. Okay, so why I am joining it with space, let me show you first without space what is exactly happening. So I'm returning this here, or you can write here final text. Okay, I'm going to return this final text here, and let me show you what is happening. So we are getting everything like it get merged here, so we are not able to understand that, okay, what is, where we are separating and what is happening. So that's why I have given here space, so that each words get space separated in the final text. So here we are getting wonderful little production filming. So that's why we I have joined it with space. Okay, so that each word gets space separated. So this is our final clean text function. So first we are removing all the HTML tags, and then we are lowercasing it and removing all the punctuations, and then we are tokenizing it, and after that we are iterating over each words, and we are checking that whether this is a stop word or not. If it is not stop word, then next level what we are doing, we are applying lemmatization on that word, and then we are returning the final word. Okay, so right now we have applied this on one element of this data frame. Now we are applying it on entire data set. Okay, for that let me save this in X, and I'm giving here df review. So df review will contain all the elements, and I'm applying it using this apply function, and I will use here lambda. I will give X, and I'm saying that iterate over each element of this data frame having this column, and apply this clean text function on that. Okay, I will give here X. Okay, using this piece of code, you will be able to apply this clean text function on each element of this review column. Okay, so this review column, I'm taking this and I'm applying that clean text function on each element of this. Okay, so that's why I have written here like this, and we can print here by using this. So it will take some time because it's applying this on each element of this data set. So we have here 50,000 elements. Okay, so we got our answer. So this is what we are getting. So this is a clean text. Okay, so here we have raw text, and this is our final clean text. Okay, so we have successfully cleaned our review column, and now we will work on the sentiment column. So we have to prepare this also. So for that I will give here y, and I will write here df, and I will apply this sentiment, and I will apply something on this also. So I will use here lambda again, lambda x, and I will give here 1. So I want to say that put that element to 1 if x is positive. Okay, so I'm saying like this because here we have two value, one is positive and one is negative. So I'm saying that if element value is positive, then put that as 1, else 0. Okay, so let me see what we are getting. So here we'll get values in 1 or zeros, okay, in binary form. So we successfully got our x and y. Now we have to prepare our training set and test set. So for that we have to split data in training and test set. Let me give here markdown, and to do that we will use scikit-learn. So I'm using from sklearn dot model selection, and I will import train test split. I will define my x train, x test, y train, and y test. I will use here train test split, and I will give here x and y, and I will give here test size. Test size I am giving here 25%. So I want 25% in the test set and rest all in training set. Okay, so let me run this. So we successfully got our training set and test set. So here this is our training set, and if I do the shape, then I will get here. Okay, so this much is 37,500 is x train, and what about y train? Y train also will be same. So y train will be also same, and same if we do for test set, x test and y test. So 12,500 example we have in the test set, and 37,500 examples we have in the training set. Okay, so if I print here this training set or test set anything, then we are getting here these examples in the form of text, and we have to convert this in numbers. Okay, that is in vectors, because these machine learning models will always understand things in numbers. It will not work on this text. Okay, so we have to properly convert this text in numbers. Okay, that is in vector form. This y train is already in numbers. Okay, we have already encoded it in 1 or zeros. Okay, if it is positive then it is 1, and if it is negative then it is 0. But we have to work on this, and we have to convert these text in the number form. Okay, so this is what we are going to perform in the next video. So in the next video, we'll use TensorFlow text vectorization things to vectorize these text and convert it in numbers. Then it will be ready for training. Okay, so if I summarize it, so what we did here, so first these are the steps to install all the libraries, and here we have downloaded the required things like stopword and wordnet lemmatizer, and here we have loaded our data set, and we checked that whether there is any nan values or not. So there is no nan values, and after that first we encountered with this HTML text, so we want to remove this. So for that we use beautiful soup. For that we removed all the punctuations, and we perform lowercasing on that, and then we use NLTK word tokenize to tokenize our text, and after that we removed all the stopwords and we apply lemmatization, and then we returned our final clean text. Okay, so this is a clean version of the text, whatever text we have here. So this is a clean form. So here we encoded our sentiment column also in 1 and zeros. If it is positive then it is 1, if it is negative then it is 0, and after that we here splitted our data set into training set and test set, with 25% part in test set and rest 75% in training set. So this is what we done in this video. So in the next video we are going to perform vectorization on these texts. Okay, so that's all for this video. I hope you like this video. Thank you guys. Thanks a lot for watching this video.